Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Today's episode, I wanted to kind of give some in-depth knowledge, what I could see so far. Again, it's been all quiet on the Dragster front. I wanted to talk about some of these things, kind of put my own knowledge into there, not leave everybody with just nothing. But hopefully I'm recording this a handful of days ahead of time. Hopefully nothing major happens between here and there in the next couple days. And it's still relevant by the time this comes out, because I do need a little bit of time just to do some minor editing and stuff like that. So I'm going to call this, we'll get into some full Top Thrill Dragster 2 anal.
Now get ready.
Cis.
Now get ready.
Anal cis.
Now get ready.
Analysis. There we go.
Now get ready. Here we go.
Welcome back to the Ryan Ride Mechanic channel. For those of you that are new and this is your first time here, I apologize for that intro. For those of you that aren't new and you've come back for a lot, then about par for the course, right? That was funny, huh? I thought it was. So on today's video, I wanted to talk about a Dragster and see what's going on. I've been watching YouTube. I watch everyone's videos when they put out like updates and this and that, and everyone's kind of doing the same update video, basically that they're updating that there's nothing to update. So I too thought about making an update stating that there's nothing to update, but that information's already out there. So why bother doing that? So today's video, I wanted to talk about what we have seen and what we know. So let's get into that. First of all, if you haven't already, make sure you subscribe downstairs, hit the like button, do all that stuff. It does help me out. So let's jump into the biggest topic, right? The one that we've all seen, the one that we've kind of been chewing at this entire time, which is the wheel carriers. I've got the thing set up, so hopefully you can see my mouse this time, because it really helps. All right, so let's look at this screen here. On this first picture, what we've got here is that this is the Top Thrill Dragster 2 wheel carrier assembly. This is Zamperillo's wheel carrier assembly. This was taken at the IAAPA Expo. Thank you for the viewers that send in these pictures and stuff. I really do appreciate that. Man, it's just like a showroom floor. So nice. Everything looks so nice and clean. It's amazing. So let's look at this wheel carrier and see what we can tell about it. Okay, so first of all, I've got this question a lot. Which is basically right here. You see how this front wheel the front wheel has this guard on it and the rear wheel does not. That happens a lot of times on rides where the front wheel is open, like things can get into it, and the rear wheel is covered. It's underneath the coach. Nothing can really get in there. So they typically they cover the front wheel to prevent stuff from hitting the wheel. And hopefully if it runs into something on the track, that cover is enough to deflect it away from the wheel instead of getting sucked into the assembly and stopping the wheel. Because once you stop one of those wheels out there on the track, it's all over. If you're quick and you catch it quickly, the urethane's toast and you can send the wheel in, have it retreaded, and save the wheel. If you don't catch it within a cycle or two, like it's something stuck in there, like where I worked, capes got stuck in wheels. I hate capes. But the capes would get in there and they get wrapped up around the bearing. They'd stop the wheel and it would literally machine the aluminum away as it was out there on the track. People would say, wouldn't that be making a bunch of smoke and noise and everything else? It's like, no, actually it doesn't. It sits there and sounds just like anything else. You don't even know what's happening. We went in and a wheel was like a quarter of the way gone on a wheel carrier because it was just sitting there grinding against the track. Operations didn't hear the difference. No one walking around heard the difference. So they don't make much noise when they lock up like that. You would think there'd be a lot of screeching or something, but nope, they don't make much noise. So it's very common that the front wheel has the guard, or if it's between two coaches, the rear wheel might have the guard so that people don't drop stuff down on top of it into that area. Or if it's the rear wheel, like if you're sitting on the coach and you could look down and see that wheel, that's also to prevent it from flinging stuff back up at people. because track lube and everything else, it can get sticky. It could coagulate on the track and then get pulled up and flung off. So that's kind of like a mud flap on a car. Keep stuff down underneath the train instead of back up on you. The wheel carrier assembly is pretty standard. So this is the carrier itself here, this wishbone looking deal. This is the central fork that runs down the center, spar, rib, whatever you want to call it. These things are shaped, from the front they look like this, but from the side they look like this. And they look like that because they go right around the track like that. So that's in case all your wheels come off for some reason. It can't leave the track. The train doesn't fly off like a bad roller coaster tycoon program or something like that. On the outside edge of the wheel carrier, these are the road wheel axles right here that go through. They're simply just a solid round stock of metal that goes through. This plate on the end, as you can see those 4 little yellow torque stripes right there, that plate is holding the axle captive on both sides. So as long as that plate is bolted on there, the axle can't come out. And even if you took the plates off both sides, the axle's still not going anywhere because it has no real reason to go anywhere. Those plates also put a bit of preload onto the entire assembly that prevents the axle from rotating in there as well, because it basically binds the fork assembly and pinches it all together. And then it pinches it against the inner races of the road wheel. If on the inner race of that bearing, if you loosen that race up and just allow it to sit on the axle with nothing holding it, it will start to spin and it will chew itself into the axle. Then you have to throw the axle away. That's no good. As we work our way here towards the center, you'll see this guy right here. This is the pivot assembly. And basically what that is that on the inside of that carrier, it's 2 forks put together. It's the outside of the wheel carrier basically on both sides put together, and there's a gap in between the two. In that gap, there is a big round pin. I know Intamin called this a kingpin assembly, but every manufacturer calls these things something different. So I don't know what Zamperla called that, but it's basically a big pin that's vertical. And that's what's going through the top right here. That pin sits up vertically inside there, and it's got a round hole that goes down, and then the park sticks a pin through the side of the wheel carrier right here, and then that pin is held on with caps on the outside of it. Those pins typically also have some other retainer on the inside. Like if you were to look down the middle of that wheel carrier and look inside of there, you would probably see a set screw or something like that holding that pin inside there. So even if the caps broke off, you would still have a mechanical fastener pinched in the side of that axle or that pin holding it left to right so it can't come out. Okay, so here's a different angle of the same assembly, and you could see down here, you're looking in the top of the road wheel right there. And then here is the hitch assembly, and that guy it's just a giant spherical bearing sitting inside there. Very common with a lot of rides these days. That's nothing spectacular. Hitch is bolted on, so they're easy to remove for NDT. NDT means non-destructive testing. And then there's the back side of that wheel carrier right there. And you can see the same bolts on the back side. It's the same thing. You have to remove all 8 bolts to take that axle out one way or the other. But it looks like on here that if you tried to pull the axle out towards the inside of the train, it won't come out. A lot of manufacturers do stuff like that. They put axles and things in such a way where you either have to strictly remove it from one side, or you might even have to take the assembly apart and twist it at like a 45-degree angle to pull something apart the rest of the way. So even if all the mechanics came apart and the pins started sliding out one way, it's still captive inside that assembly. So a lot of manufacturers do stuff like that for an added extra safety. And while we're on this subject, I can't guarantee this, but the frames are billet aluminum. We know that. The frames are billet aluminum. Everything down here is billet aluminum. But typically, because of the stress involved And a lot of this video is going to rotate around stress. Because of the stress involved of wheel carriers in particular, on average, even with billet aluminum frames, your wheel carriers are typically billet steel. They're not billet aluminum. They're typically billet steel, which is, it's all one, just think of it, it's all one piece steel. Like the chassis was all one piece aluminum, the carriers are all one piece steel, but the steel can handle the repetitive stress and vibration better than aluminum can. And it's safer to NDT. It's easier to look for cracks and fatigue and stuff like that. Okay, back to our other picture here. So down on the side, this is the guide wheel assembly. And I do plan on making a episode strictly about wheel carriers. In fact, I might make that soon because this is some pretty good catalyst for it. But this is pretty much almost a wheel carrier episode, but it's focused on Top Thrill 2. So that's what I wanted to look at for this video. So this is the guide wheel assembly, and what you have here in the center, these are pivots. Now the guide wheels can pivot back and forward away from the track. They do that in a very minute space. Zamperla has a unique thing to deal with because they built some track, but the rest of the track is Intamin. So Intamin typically has a pretty good tolerance on their track. It shouldn't be moving all over the place. And on these tracks like Intamin builds, wear and like movement is not typically a factor. Tracks like Vekoma's, the old Arrows, where they're C-shaped and the rails run the inside like that, those guys are susceptible to bending and flexing. So over the many years of the ride's life, they flex and they can eventually start to widen and open up, and the ride gets rougher and rougher as that gauge opens up. The gauge opens very minute, very minute. It's hardly anything. Like it won't even become a problem before the ride is destroyed at the end of its life. But that's one of the ways when you talk with a manufacturer about making a ride smoother under a retrofit or repair category. One of the first things that Vekoma always offers is to come out and measure and gauge the entire track to see if they could fix some of those spots. Some of it is manufactured that way. Some of it was from install, like when you have bind and assembly and you squeeze all those bolts together and start ratcheting everything down. The track tends to tweak a little bit in one direction and it kind of opens sometimes, closes sometimes as well. Vekoma could come out and measure that stuff and fix it. And the same with some of those other companies that go out there and they do retrofits like Premier and manufacturers like that. So we have the guide wheel pins that the guide wheels pivot on. These are, of course, the guide wheels themselves. And now the housing's pretty unique here. This is an interesting looking housing. So the housings kind of look like a B&M. The B&M, you would have this centerpiece right here that I'm framing out. That centerpiece would be gone. You'd just be able to see the wheel on the inside. It'd be essentially hollow like a fork. They didn't do that here. They decided to keep that solid. Why? Don't know. But that's an interesting look to it. Definitely gives it a more solid, finished off look. And then you could tell here that if I take this and put it around, or I'm going to guesstimate right around where the guide wheel would be in this area, essentially, right there. You could tell that there's this hole right here on both sides. Well, you got to remember, all these components are being made out of billet material, so it's heavy. They're adding a lot of weight into there. So what they have to keep doing is all these places, they go in there and they keep plowing holes into stuff to take the weight back out of it and still remain its rigidity. I'd even be willing to guess, it's just a guess, that if you looked at the stress analysis on these guys, I bet you they would say that there is, in this area, there was a lot of stress in that area, and by putting that hole through there, leaving some of the support, putting the hole in there, it actually made the assembly very strong, but allowed it to become a little flexible at the same time. Just a guess. No math backing that one up. And then this is the guide wheel bumper assembly down here. Now, guide wheel bumpers are really interesting. You see two parts to them. One are the springs back there, right in the back, right there. Those springs do some of the raw movement, and when the track gauge suddenly closes in, those springs keep everything close to the track. And they don't want the wheels going away from the track, because if you let the wheels go away and slow down, then they basically start skidding on the side, and you could wear the wheels out really fast. So they don't want to do that. So what they do is they put springs on there so that their wheels are always pushed up against the side of the track. Do the springs actually center the vehicle on the track? No. Do they add anything to the ride? No. They're pretty much there for just the occasion that the train starts hunting side to side. It at least keeps the wheels touching the track while the train is hunting side to side. So you say, well, they adjust those things. How do they do that? Well, a lot of manufacturers use eccentric axles. Now, an eccentric axle basically means eccentric is you have your axles round like this, and then the piece that goes through the center, through the wheel, is actually smaller, but it's offset. It's not dead center, it's actually offset to one side. So that means as you rotate that entire assembly, that offset gets closer to the track and further away from the track. And that gives you finite pressure adjustment. What Zamperella's done, since the axles don't look eccentric. So they look like they're solid axles, which is fine. And then the movement that they did is right here in this assembly. These are the main adjustment bumpers that sit there. That is what actually takes the force. That is what actually keeps the train running centered down the track. You've seen pictures of the stators with tape on them. That's because the train was impacting the stators as they went by. So on a Skyrocket, on a Premier ride that we had, these bumpers were too soft. They were way too soft. When they did the math and actually built the ride before that, they used the exact same bumpers, so it was fine. Ours had too much stress on it because they changed the track design, and it was a brand new prototype track. So there was way too much stress on those bumpers, and it actually allowed the wheel carrier to twist. Well, when the wheel carrier twisted, it let the road wheel actually run off the center line of the rail. It was twisting that much. And the outcome of that, it wasn't really a safety issue. The outcome of that was that we kept losing road wheels. We kept coming in, and the road wheels I'll show you. The road wheels, basically, when it came back in after, a day or two of running, the inside of the wheel was delaminated right here. This side was fine, but this side was delaminating. And it's like, man, why does it do that? Took a long time dealing with it, and eventually I got it. I stuck a camera above the road wheel assembly, and we watched it during a cycle. And then when it got up there and it started getting under hard loading, you could actually see the guide wheels and stuff pull away from the track, and the road wheel started shifting over like that. And then that side that was in there still, that was running right on the ragged edge of the thing, was the side that was delaminating all the time. So we had to go back, and Premier made stiffer bumpers to put in that location. So these bumpers are extremely important to what happens. So a lot of that shake side to side that people feel, that could be minimized by putting more crush into the track. Now, crush is something that, obviously these bumpers are made out of rubber in here, and the wheels are rubber around the track. So what happens is that when you tighten all that assembly up, steel to steel, you just go till it touches and you're done. But when everything is rubber and urethane, well, you can go till it touches, and then you can go further. So it's kind of a very unique feeling. Some rides use what's called a control track, And what they do is you'll actually move the train to a part where the track is actually narrower in that section. It might actually have a piece machined off the side of the rail, but the track is actually, let's say, 4 millimeters narrower in that area. And then what happens is you set the train right on that section, and you adjust your guide wheels until they just touch. And they're just touching. It's like, okay, they touch. And then when you move the train back out of that control area, now you essentially, on both sides, you have 2 millimeters of crush on both sides that's keeping that train centered. So a lot of people were telling me that the train hunts really bad on, I believe it was just a higher speed. So profile 2 and 3. 2 as it goes backwards up the spike, and 3 as it goes over the top hat. They said that the train hunts really bad, or hunts, that's shaking. It shakes really bad side to side as it's going down there. That's also referred to as hunting. It's where the train's looking for center in the track. So one of the ways to reduce hunting in a ride like this is to take those guide wheel bumpers and over-tighten them to make the assembly tighter. And you say, well, why don't they just keep doing that? Well, you can only do that to a certain point. You get them tighter and tighter and tighter, and then you start blowing the guide wheels apart. So the guide wheels can either start to delaminate where they have some white powder coming out of them. That's the urethane bond. Or they can literally start to melt. Like I've run upstops and guides too tight on impulse coasters, and literally they melted the urethane. It came back looking like a spider web / cotton candy all over the side of the train. The urethane got too hot, the urethane melted, and then once it melted, it slung everywhere, all over the place. So that is a danger. You got to remember, these vehicles weigh tons. There's tons of weight with people on it and everything else. People doesn't account for much weight, but it's still there. And you're adjusting these small things which make up a lot of friction in this entire assembly, and you've got a massive drive moving it at 120 plus miles per hour. So the margin for error is a little smaller on these things because that drive doesn't care. It's going to move that ride one way or another. So you better make sure it's adjusted right. Okay, so since we're doing all about wheel carriers, let's do some wheel carrier 101 while we're here. Again, I'll make a video about it. And when I make the video, I'll just cover some different types of wheel carriers. The premise is still somewhat the same, but the execution is a little different per manufacturers. So this pin that's vertical right here, that allows that whole wheel carrier assembly to turn left to right. So when the train goes around a corner, that allows it to turn left and right as it goes around the corner. The guide wheels are the ones that actually push the carrier assembly to the left and to the right. So as the track starts to go to the right, the rear guide wheel gets pressure on it and it starts pushing the wheel carrier to the right along with it. That's the reason why the guide wheels are in line with the road wheels. The center of the guide wheel has to be in line with the center of the road wheel. And those are. And then underneath it, this pin, this is the horizontal pivot. That allows the wheel carrier, let's think about it as a train's going forward and it goes like onto a lift hill. As it starts to go up to the lift hill, that allows the wheel carrier to pivot and actually twist and go up. So you have two ranges of motion for that wheel carrier. It can swing forward and backwards, or basically go up and go down, and then it can also twist left and right as well. And then it's also noteworthy on these that the original Lightning trains that Zamperla rolled out, because remember, this isn't the very first time they made a Lightning train. They made one a year or two before, just as a, hey, look what we're trying to do, where the whole thing was completely modular. So this Top Thrill 2 did not get that modular design. It got a solid design, because on the modular design, the wheel carrier assemblies were much more stout. They were much heavier. And everything, the wheel carrier forks right here that went on, everything was bolted. The same with the guide wheels, the same with the upstops. All that stuff was bolted on there. But these designs, I'm guessing because of the size and what they needed it to be, plus the weight, they went with a solid one-piece design. Okay, so let's go away from looking at those guys and let's move into some of our... At this point in the video, if you haven't already, please make sure you like and subscribe and give me some comments down there. Let me know if you got any fun stories to add on to these. And then let me know if you want to see something for topics in the future too. I'm always up for new stuff. I've got a list of things that I'm making, but sometimes somebody says something and I'm like, oh yeah, let's do that one real quick. That really sounds like fun. I do enjoy getting that information. You guys come up with a lot of good ideas for videos, so let me know if you got them. You can also email me at ryantheriotmechanic@yahoo.com. Let's get back into the video. So let's go into the upstops now. Since I couldn't show you on the other picture, I'll show you on these guys. Here's the upstop assemblies right here. It's pretty much a carbon copy of the guide wheel assemblies. They're just a little bit smaller. All right, enough critiquing there. If we look at these two designs right next to each other, we'll see the difference. We'll see what happened. Right here in this area, right there, between these points, they've added these plates in right here. Now you can see underneath, looking underneath, there's no plates underneath there. So that tells me that they didn't have any trouble with the upstop assemblies. It wasn't the upstops that they were watching. Okay, so the fact that they added the plates in right here, underneath those forks, that tells me they're looking at either the road wheel assemblies or the guide wheel assemblies. Now, looking back at it, a lot of people said that shake. Remember, Profile 2 and Profile 3, they have a really bad shake. And then the ride got shut down. And then these plates showed up on there. Now, could those plates be welded on there? Yeah, they could be welded on. Absolutely. These wheel carriers were shipped off, probably back to Zamperella. And Zamperella probably welded those plates onto them. Now, I originally thought that they had just manufactured new wheel carriers, but it doesn't quite support that now. I mean, sorry for the grading in the way it's kind of hard to see a lot of this stuff, but you can see there's the plates right there. So as we see the plates right there added to both sides, and you see that clear line of definition right there. So there's definitely the original carrier where it steps inside, and then there's that plate sitting right there. Well, if you were going to make these wheel carriers over again, which is what I originally thought, that they were made over again, like they were brand new. If you were going to make those carriers over again, why would you put that step in there? That would all be one smooth machined piece. There wouldn't be a big giant step in there, which is a stress riser. So that does point to the fact that they probably welded the plates in there. Generally, rule of thumb, you don't weld billet. Just, it's not great to do, but it can be done. I mean, they've probably done it plenty of times before. But it's not one of those things that's like, oh yeah, let's weld billet together. It's typically not a thing, but yeah, you can do it. So that would just tell me that if this is the final design, if this is the final iteration of the repair that they're going to do, that they will more than likely, they will remanufacture the wheel carriers with that all just being one piece machined metal, so you don't have any welds in there. So there's two things that these plates can be doing. The first thing is that they could be taking road wheel load. Like for some reason, the fork arms that are sitting out holding the wheels on both sides, for some reason they're deflecting too much up and down, and they needed support. I don't put much stock into that, because if that were the case, you'd have to have the same thing on the opposite side. And on the opposite side of the wheel carrier, there's nothing there. On the opposite side of the wheel carrier, there's nothing to mount those plates onto down there. So on the outside, the plates go down and mount to the guide wheel assemblies, basically. On the inside, there's nothing underneath there. There's no track. So you can't support that inside arm. So if the carrier arms were deflecting a lot, like they were being overloaded, by supporting one side and not the other, you're now adding torsion into the assembly, where one side's going to stay straight and the other side's going to try to flex like that, which is going to twist everything. It's going to create torsion in the assembly, probably going to tear the thing apart faster and crack it apart and everything else. That wouldn't be a good thing. So if you look at this guy, they put these plates right from there and they joined it right down to where the guide wheels are. And look at it. So basically they went from here to here and then down right into that corner, right down here where those pivot pins are. They welded them down right there. You can only go down so far before you run into those guide wheels assemblies, and then they're going to have to stop there. So they welded that whole thing. So my big question became, are they doing it to reinforce the guide wheels? Remember what I was talking about earlier, where that guide wheel bumper assembly down there absorbs that shock load as the train's running back and forth, and it keeps the train centered and it keeps it running straight. And remember, everyone's talking about the train hunts really bad at high speeds. It's hammering left to right, left to right. Well, maybe they tightened down those bumpers as tight as they could go, and the thing is still hunting. And then maybe they found a crack somewhere. Now, maybe the crack actually appeared somewhere in this area, in the webbing itself, in that vertical support rib. And then you could probably monitor it, watch it, put strain gauges on both sides. They sell those. I mean, they're not hard to get a hold of. They're actually just, they stick right to the side of the assembly. It looks kind of like a little, like something you would have on like your credit card. It looks like a little chip that you put on there with a couple wires coming off, and it measures how much the steel is moving while it's running. So they put strain gauges on there, and they figured out that maybe that center rib, this is one of my thoughts, is that center rib was deflecting. It was doing this while the ride was running. So even though the guide wheels were tight, the bumpers were tight and everything else, when the train tried to shift over, that rib essentially deflected. And it wouldn't take much, because you figure everything running straight and true, it would, it was only side to side movement. You can't just open and gauge and close it. That's all it would be doing. But when it comes down off that tower, the added weight of the people, you start introducing a side to side, especially when you go over the stators. The stators could be pushing a little unevenly, one side or the other. And then you would introduce that hunting into it. It would start hunting left to right a little bit more. And then once it starts hunting, that rib starts deflecting, and then it can't stop. And then as the ride just goes faster and faster, that rib just keeps deflecting, and the whole guide wheel assembly with the rib is being twisted left and right like that as it's going. That's one of my theories of what's happening with this thing. That rib was being deflected while it's running, and a crack showed up in there, and they're like, how did that crack get there? Obviously they shut the ride down, because you can't have a crack on those things. And then they found out that the rib was deflecting, and it was shifting all over the place while it was running. And then they probably put some strain gauges on it and measured it, and they said it's moving a lot, way more than the math said it would. Because originally, they had plenty of engineers look at this. It wasn't just one engineer at Zamperla that did the work and they said, yeah, it's fine. They had a bunch of engineers look at this stuff, and everyone agreed that it was okay before the ride was even built. So the knee-jerk reaction was to put these ribs in there and say, let's see, and this is a test. This is probably one of the reasons why the ride's not open yet. Again, it's a couple days before this video releases, so not open yet? Maybe, I don't know, but that's probably one of the reasons why the ride isn't open yet, because they had this problem, and my thought, it was where the train was hunting too hard and it was putting too much flex and strain into this entire assembly. And they said, how do we fix this problem? Well, there's two trains of thought. Trains, right? Get it? Trains? Okay. There's two trains of thought. One, the design crew back there started working. They literally took the first wheel carrier design and threw it away. And they're pulling out revision 2. They're like, okay, here we go. We're going to make the center body wider. It's going to be much more stable. And we're going to do all this stuff. And then the knee-jerk reaction side of that fork was, let's weld gussets on it. Let's weld these stiffener plates in there and see if that does it. Now, the two are probably working in conjunction with each other. They put the stiffener plates on everything, and the one crew was like, I think this will work. I think we can get out there and safely open this back up, and we'll have no problems. Cedar Point, obviously, yes, let's get the ride open as soon as we can. Safety first, right? It's always got to be safety first. So anytime I say that stuff, we're not jeopardizing the safety in there, right? So they're going to say, okay, let's get the ride open as soon as we can. So they go, okay, so they took these off and they shipped them all back to Italy or somewhere. And they said, okay, weld all those plates back on there. Why did they have to go to Italy for that? Trust me, it happens with new stuff. When there's a problem with a brand new part on a train, it's got to go back to where it was so they can put it back in the same jig, in the same fixture where it was made, and they did all the QC and everything else to it. So when they weld it back together, they had it in a controlled space with the people certified in that process. They knew what they were doing. Like, they had 100% control of those carriers when they were fixed. It's like, okay, so they brought them all back. They put them on the ride. They started testing. Awesome. Loading cycles on it. Let's just get more and more cycles, more and more cycles, more and more cycles. They stopped testing. Then what happened? NDT company showed up. Uh-oh. Is that a problem? All right. I don't put too much stock in the NDT company showing up, non-destructive testing, simply because our NDT guys we had at the part that we had to have come in, because even though we had people certified for NDT, the insurance wouldn't allow it. You couldn't have your own company signing off your own inspection paperwork. It's just not kosher. So the insurance company says, nope, it has to be a third party to sign off the final NDT paperwork. So this wasn't testing from Italy. Not like they welded it in Italy and brought it back here and said, okay, great, let's test it here and make sure the welds are okay. That wasn't the case. It was obviously done in Italy. Trust me, it was. Before they brought it back over here. So they put it on, they ran it. They ran it and they ran it and ran it. And then they said, you know what? We think it's doing good. We need to NDT everything. Again, just to make sure we have nothing. And while they have those gussets working on there, it might go through a schedule if they open the ride in this condition, it might have a schedule like, hey, every 7 days, all the wheel carriers have to get NDT'd. And they might open it up on one train. And it might run one train for a while and then 2 trains. And then at the 7-day mark, they lose one train again. NDT company comes in, has to NDT all those welds. Gave it a clean bill of health, certify it, sign the paperwork off, come back in another 3 days for the next train. Now that could be what is happening. And then during this process, the people back in Italy, in Zapparilla, they're getting the other side of this conversation. So what do? We put these plates on there. It's like, great. And then they put it out there and they start testing it. And they say, what's it doing to the stress of that rib? What did our reinforcement actually do out at the ride? What did it do? And it did this. And they're crunching the numbers again. They're like, is what we did sufficient enough to safely open the ride back up for the rest of this year? Because remember, Cedar Point's sitting there like, all right, we're not going to accept a 3-week repair or a 3-month repair. we need this repair to get safely through the rest of this season until we go down for the off season. That's what they want. They want that guarantee that it's not going to be, we're going to open back up, and then 2 weeks later, it's like, oh, never mind, got to shut it back down again because we found another crack in there or something. So they want that guarantee. So if the stresses and testing look good on this particular repair, that might be enough for the engineering back at the office to say, yes, let's move forward with widening out everything and remaking those wheel carriers to a different spec. Now, if at the park they didn't like the way this design is sitting in there, and they're like, no, this isn't great. We have billet parts that are welded together. We've got center ribs, those reinforcement vertical ribs that have an unknown amount of fatigue on them that are in a high stressed area to start with. It might just be too sketchy for Cedar Point to say, yeah, that's good. Let's go. You hear me say it all the time, like, you have to get the warm, fuzzy feeling before you open something back up. You can't just throw caution to the wind and say, oh, it's good, open it. You have to get this is going to work. This is going to be fine. You got to remember, Cedar Point has a lot on the line. Zamperla has a lot on the line. So both companies are working at this, and they don't want to make a mistake. So they might have gotten these things on here and done the testing and said, yes, this is good. That's the direction we need to go. Look, it solved a lot of these problems. It solved a lot of these mechanical issues that we were having. And then they could have said, instead of saying, hey, let's open it up, they could have said, we're going to wait till the brand new wheel carriers are built. 100% brand new billet steel wheel carriers coming from Italy, the new design, the new revision. They said, we're going to wait until those are here in place and we could put those on. So this whole process might have been simply just to test a repair for revision 2. That's all it is. That this whole process might just be, this is revision 1.9 that is going to lead into revision 2. Do we know anything for sure? No, we don't. The NDT company could have just been there, NDT and another ride. I know we had our NDT company come in day and night, nights, weekends, whatever we needed, because anytime we made a weld repair on any ride whatsoever, it doesn't matter if it was a little kiddie ride or a major roller coaster, that NDT company had to come in and certify the weld before we can operate it again, or before we could release the parts or whatever it was back into service. So I don't put a ton of stock that NDT company was here for Top Thrill 2. Now, what I'm doing with this entire video is just simply drawing a line through everything that we know. We know the wheel carriers went away. They came back with gussets on it. They went into testing. NDT companies showed up. They haven't opened the ride. They haven't said it's getting close to opening. But they did say that we have a date, when we have a, what did Tony Clark say? He said this is not going to be a summer-long thing, which is true. I mean, if they say, yes, this is a good repair, we want to make new wheel carriers. How long do new wheel carriers take to make? Well, let's see. It depends on where they're coming from, but you could take that design and the mill spec steel, and you can get that sent out and have it multiple places making it. Although I would assume for the quality assurance reasons, you would want all of them coming from one place. Doesn't necessarily have to be Zamperla, but you want them coming from one place, just so you know if there's a problem, you only have one problem. So that could be what's going on there. The other thing that popped up more recently was like, hey, they took Rose off the train. And I was thinking about, like, why would they take Rose off the train? They've been working with the restraints. They've been working with some of those little things on there. You could see them tinkering with some stuff here and there. And I'm not sure why they would want to take something off the train unless, going back to these guys, weight, all that stuff, unless they wanted to see what a fully loaded train would be like missing 2 rows or 3 rows of weight. I really doubt it. I really doubt that. That just doesn't seem like something to do. It's like, oh, what would it be like without this weight? It's like, well, just don't load the train up. That's what it would be like with that weight. Like, that doesn't seem like well, why would you do something like that? It could also simply be like, Zamperella's design is completely modular, where they're like, oh yeah, if you have problems with seats and stuff, you just unbolt them and take them off. And maybe that was simply just Cedar Fair's way of saying, hey, let's do that. Let's take some off. We're having trouble with some of these other seats, maybe. Let's just take them off and see how easy it is, because they want the crews to know. Like, so when the crews have troubles with this stuff, hey, we just take that off, take it back. If I were Cedar Point, hopefully I would have purchased about 4 to 6 sets of those seats, the whole row worth of seats. And then I would paint them the corresponding colors to the train. And then I can literally have them keyed up, ready to go, sitting in that shed down there. And then it's like, okay, you could start rolling through refurbishment and stuff like that. You could take 2 rows off. You could take a row off and replace it with those seats that you've just refurbished. And then literally rotate the refurbishment through the train like that. Or you could simply just use it like, hey, we're going to make a repair and we're going to take those seats out. And that's the end of that. We'll just use the 2 other seats that we have. So there's basically your before and after pictures right there. On the right side, you've got the before with no gussets on it. And the left side, you've got the after with gussets on it. I really do kind of feel that since they haven't opened the ride back up and they're having NDT out there, let's just say that the NDT is for Top Thrill and they're just preventatively checking for cracks on there. Maybe they're coming up with a interim NDT schedule that they're going to have to use to make these things work. Maybe for a couple of months, maybe for the rest of the year. We're not quite sure yet. I'm going to say that this is probably just a test for Revision 2. And then in my mind, just the big question is, does Revision 2 hit the train before it opens? And that's what we're waiting for. We're waiting for Revision 2 to show up on site. Or is Revision 1.9 going to open up if everyone gets that warm, fuzzy feeling? Just wanted to add my speculation in there. Again, this is nothing concrete. Again, it's just my experience mixed with what I see happening, what I can think of going on, what people send me, picture-wise information and everything else. And for those of you sending me information and pictures, I do appreciate that. If you haven't already, make sure you like and subscribe down there. That stuff helps me out. If you want to send me pictures or any other information, you can always email me. My email is ryantheridermechanic@yahoo.com. And yeah, we will find out what's going on soon enough. Eventually, everything will come out. And I really hope they get it resolved. I think Zamperella's got a clear winner here with this train. It's just going to take a little bit of tweaking and some figuring out. And then once they do, I think they're going to be quite a popular item amongst a lot of parks. So I do feel that we'll see more of these in the future being bought up. I'm Ryan the Ride Mechanic, and as always, stay off the air gates. Bye.